how many of you have heard of generative AI? Okay, good. At least that's like about 80%. Like the rest 20%, like, just try to read a little bit on the aspects of Gen AI, because there are different ways in which you use it. This is by no means a sales pitch for Gen AI or for AWS or any of that. Like, it's mainly just what I did, what we developed, and what we delivered. So with that, today, we are actually going to look at some of the impact of generative AI at Amazon. I work at Amazon. The intro slide is coming up in a second. And then how Amazon ads and AI come together, why it's important for you to have creatives or multimedia. And then we'll deep dive into the architecture of how the inference systems work. How do you, for a given input, you get the necessary outputs, so on and so forth. And then we'll end with some key takeaways. So for the folks who have not heard about generative AI or those who have not used Gen AI, you'll at least get a sneak peek of what's all it about and the sort of the different applications that it can have. So, and that's what we're going to do over the next, I would say, 43 minutes, okay? Or sorry, 47 minutes. And with that, I'm Nikhil Nanivadekar. I'm a principal engineer in Amazon Ads in creative tech. And essentially, if you go to Amazon, you search and you find an ad, the look and feel of the ad, how it looks, that's pretty much my team and my job. We try to make them look better, we try to make them look more appealing, and we try to keep them fresh. So today, I'm going to present the progress of delivering AI-powered tools that aim to help us as Amazon advertising help all our advertisers throughout the funnel. As in, if someone who is about to buy something, or if someone who is just trying to search for stuff, for that. Now, with a show of hands, how many of you have heard of Amazon? Cool. Okay, that's encouraging. Awesome. Okay, how many of you have heard of Amazon as the website where which you go shop? Okay, cool. All right, so yeah, that's what we are going to look at right now, and the web services that we use to power all of that, that's on AWS. All right, so just a history down, just a walk down the memory lane, because there were a few folks who are still trying to get to know what Gen AI is. So the trend kind of started from 2023, but the work was started even much more before that, right? It's like us writing any software, right? It goes to prod. That's when everyone's like, oh yeah, it's live in prod, but you have to do a lot of work beforehand. Is that right? So in 2023, it was much more about hey, what exactly is this Gen AI thing? Is it secure? Now do I do a prompt? Do I become a prompt engineer, et cetera, et cetera? But what's important is we are witnessing an extraordinarily different technological transformation. 2023 was just 2 years ago. Gen AI was an emerging concept. It was primarily discussed in media, at conferences, at blogs, et cetera, et cetera. Now, when I'm walking down the street, every second conversation is pretty much about Gen AI, right? At that time, in 2023, many people were asking, okay, what exactly was it? Then in 2024, what ended up happening was it became the year of production, because in 2023, people started to actually understand the concept, and then 2024, they started to actually implement it across their projects. So, for example, if you have not tried some of the Gen AI coding tools that are there, again, they're not perfect, Holly showed earlier in the keynote. They're definitely not perfect, but they are something. It's and remember this is just the start. It's only going to get better, right? Think about it as, how many of you remember dial-up connections? Okay, cool. Most of you. Awesome. So it's like that. Now everyone expects Wi-Fi, right? We don't, Now you don't hear that Ethernet handshake or anything like that. And everyone expects like really high speed like internet, right? Do you remember even when like an image had to be buffered one line at a time, right? Exactly. And now we are watching like videos, right? We are watching full movies online with just internet. And that's the thing, like that's kind of the progression. Just the fact is like it took, I would say, about a decade or 2 decades for internet and everything to like really get mature and really start to work. Now Gen AI, like that timeline is just getting compressed. Like things are getting like out to market much more quicker. So if you look at it really, how the generative AI stack stands is like you've got applications that leverage LLMs. For example, there's Amazon Q, there's AWS App Studio. So if you all have not used Amazon Q, it's kind of a dev assistant that is available. It is kind of an assistant all throughout. It just helps you write code, build applications, et cetera, et cetera. You should try it out. And then there are other tools which give you access to LLMs out of the box, like Bedrock, right? And with that, you can just have a chat interface and try doing stuff. And then there is other stuff like infrastructure and training, et cetera, et cetera. But this isn't merely a technological progress. It's actually a paradigm shift. The example that I gave before, of dial-up internet to high-speed Wi-Fi, it's similar to that. It's a paradigm shift, okay? So now whenever there is this kind of disruption, first thing that all of us worry about is like, okay, is AI going to take our jobs and stuff like that? But there are enough codes, and I am a firm believer is that AI is not going to take our jobs. Rather, it's someone who really knows how to use it, right? It's like computers did not take away any jobs. It's actually the people who could make use of that, how to develop the software, like all of us, right? We are actually able to get the most out of that computer, right? That's the thing. And there are tons more of these quotes that I'm not going to bore you with it, but instead just go to thing when I asked before, have you heard of Amazon? This is, for example, Amazon, where last year we launched something called as Rufus, where you can actually have AI-powered searches now, where previously if you had to compare between different products, you had to go through each one and then figure out. Now you can literally just ask Rufus to do the comparison and give you the result so that you can make the decision. There are innumerable such examples. The other one is just from a help perspective, where let's say in the fulfillment centers, previously people had to go through tons and tons of manual logs and instruction manuals. Now they just ask a question, and by referring to all that very rich index of data, they get the responses that they can use. And then similarly, in terms of even coaching the customer service people, now we actually have AI which inspects how the conversation was and what exactly happened and what were the positives, what were the areas of growth, and so on and so forth. And this is so that again, you don't need a continuous monitor, but then you're actually automating this process, right? It's also a quick feedback loop. Right? Now that brings me to actually getting into what we are going to discuss right now. It's about the multimedia creation, right? So first of all, when we launched image generation, that was in 2023, okay? And we are going to look at the architecture of it. The main reason why we launched that was because we wanted to create a product that is actually going to help simplify the life of our customers. Right? Again, as Amazon, you will always hear this out in media and everything. It's really the culture of the company where we're keeping customers first. So every single thing that we are doing it from the perspective of how can we make the lives of our customers as easy as possible. So in this case, we decided to do image generation. Now, why was that, right? When you go to, let's say, Amazon, At that time, let's say this was one of my search pages where I was trying to do men's running shoes. I like to run. What ends up happening is like the typical search result page on Amazon is it just produces results. The results have details like there's the product image, there's the product name, there's price, there's the prime promise that you will get it in like X days and so on and so forth. Now, as a shopper, when you're like scrolling through these results, it's literally our job as Amazon to aid your shopping journey by giving you the necessary information, for example, star ratings or bestseller badge, etc. And all these important components, we put them in the search result page so that it helps you inform your purchase decision. Now, similarly, if we look at the detail page, like all of you must have seen a similar page like this when you're buying on Amazon. It has a product shot, it has descriptions, price, delivery timelines, customer reviews, right? The whole idea of a very good or an exemplary product detail page is that it addresses the purchase barriers. It has descriptive content, it tells the brand story, it provides new, precise, non-repetitive information, and also it has a highly impactful, high-resolution image. Because guess what? The first thing that you see is that image, right? So you want to make sure that it's actually attention-seeking. So when we did research, we actually found out that there are many ways that brands can engage with shoppers. And shoppers actually, there are many ways in which they spend their time, both online and offline. And that's when we realized that like in order to draw meaningful attention and engagement, you need to deliver visuals that are not only on brand, but also timely and relevant. Okay, so that brings us to the first creative barrier, which is the lack of visually stunning and seasonally relevant content. Because if it is the same creative over and over again, you're going to be like, okay, it's the same thing, right? But the reality is that the tight timelines and limited resources, because producing this high quality content actually takes time, and it also takes money, right? That's what makes it incredibly difficult to consistently produce effective creative assets, effective multimedia, right? And on top of that, the stale content always fails to connect with the shoppers. So the brands have to always stay on top of the latest trends that are going on, the seasonality that is going on. Like right now, summer is coming up. If you were to show you like, winter themes of like, Christmas and all, it really doesn't resonate, right? So you can see how all throughout the year, you're going to have like, the work that an advertiser or a brand has to do just so that they can engage with the shopper, right? So what we did was, and there's a quick video coming, we decided to launch Image Generator, as I mentioned, in 2023. So the way it works is, and I always like to first show the final product and then show the architecture so that it correlates. It's so easy where it's the whole story of like one click, where all the advertiser has to do is select their product, and then when they go to add image, they just say, choose an AI-generated image. Behind the scenes, our AI actually goes, figures out what that product is, what will be the best, creative asset for it, generates them, and gives them to pick, and then they can submit a campaign, right? And once they submit a campaign, it's actually visible for the shoppers, like all of us, right? That's how we build Image Generator. Do you all want to see like the actual architecture of how all that happened? Like that 1 minute, 32 seconds. I see a lot of, okay. I'll cut to the chase. So this is a very high level architecture diagram. And when I say very high level, it's like 100 feet view, right? The advertisers enter through what we call as the UI that you just saw. We call it as Amazon Ads Console. When the advertisers want Gen AI images, we trigger a process on the back end. using the Amazon product detail page details, any inputs from the advertisers, we pass these to our image generation inference step, and then the output of the image output are a set of images that we show to the advertisers, as you just saw in the video. Now, at this point, all of you must be asking, okay, but Nikhil, how does it really work? Like, you have told us so many high-level things. How does it really work? Cool. Let's dive in. So we are going to focus on the image generation inference piece of it, because everything else, like around it, it's kind of there to support that. All right. So this is how, like, these are pretty much the steps that are laid down for how the image generation actually works end to end. Essentially, we came up with a collection of models, and we needed to deploy them to prod, and we needed to chain them together, because we did a few prototypes, and we identified that there were certain pre-processing and post-processing steps that were required so that those GenAI outputs, so that we could first produce the necessary GenAI outputs, and then we could actually use them by surfacing them to advertisers in production. Right? So again, if you remembered some of the slides before, it's going to be important of not just using AI, but like knowing how to use AI. Because we found that it's we do need to supplement it with some pre-processing and post-processing. Now, over here, if you see on the leftmost side, it's we call something called as the product image selection that is there. So on the detail page that you saw, we need to have the actual image of a product to use it, right? That's what's happening there. And then you can also see that there's the salient feature extraction box at the top. So for the products that are there, we actually go and parse out all the necessary details of that product, which helps us create that image. Okay. Now, using the selected product, we use ML models to actually segment that image so that we can remove we can actually separate the actual product image from the background, and so that we can only use the product image. Okay. And now we have the product shot, the salient features, and we use our own. So now we have the product shot, we have the salient features, and we use our own fine-tuned LLM to generate prompts. These go in as inputs to generate concepts. Okay. So you with me so far here? Cool. Okay. The text to the image generation model that is there at this point is prompts. Okay, and those prompts are actually telling how exactly that image should be. We detect whether an image is of acceptable quality, or we need to upscale it, we need to improve its resolution, and so on and so forth. And after that, we pass them through the responsible AI filters, and then surface the generated images to the advertiser. And then, if you look at, and I've tried to put some numbers out there. I apologize that the font is a bit small, but if you see whenever we are creating prompts, we actually create n prompts, and then using the n prompts, we create m images per prompts. Okay, so that results into generation of m times n images. It's just a Cartesian product. Now you would say, Nikhil, why do you do that? Is that wasteful, right? Well, the most important thing is we want to provide advertisers the variety, okay? And this is our way of actually giving them variety by generating different prompts and generating different images with the same prompt, okay? And that's why we use the Cartesian product. And then we select the top X images, and then we show it to the advertiser. Now, this is how the entire start to end image generation workflow is structured, okay? But how did we really get here? Because this is, again, in 2023, okay? And in 2023, we were still like figuring out how exactly all of this thing works. So how did we really get here? Okay, the answer for that is prototyping. If anything you can get out of this talk, like I would want you to get out, I would want you to take away that iterative development and prototyping are actually one of the best tools that we have as software engineers. Because you want to prototype, you want to run things so that you can test them and learn from them and then improve your product. Okay? So prototyping and iterative development was the way to go. And what we did was we actually iterated on multiple models. We had multiple scientists doing that. Some of them were one-shot models. A one-shot model is where you send the input and you get the output, just one shot. Sometimes we had to daisy chain the models because, let's say model 1 would do something, model 2 would do something different, model 3 would actually sync things together and then give the output. And then since the produced content, one of our biggest problem was actually all the content that we produced was extremely subjective, right? Because if I found something really good, it's not necessary that my colleague found the same thing to be good. Has that happened the same thing to you when you write a piece of code and you're like, oh my God, this is so good, it just makes me so happy, and then you raise a pull request and then you get about 15 comments on that? Has that happened to you? Who has it happened to? Pretty much most of us, right? Where you're like, okay, but I thought this was a masterpiece, but no. And that's the thing, but at least with code, you know that there are certain best practices. You can write a unit test and say this is good or bad. But stuff like multimedia generation, what ends up happening is what I like might not be something that my colleague likes, and vice versa, right? So for that, what we did was, if you see up top there, we use something called as the Amazon SageMaker ground truth. What that allows you to do is essentially create jobs. And using those jobs, we can have human annotators, who are evaluators or reviewers, actually label them that whether something is good or bad. And using that data, we are actually able to improve our models. Okay. Now, all the models that were there, we kept it in a model registry, and this was super important because we wanted to have versioning. We wanted to see how they play with each other, how they work with each other, so on and so forth. And then it's the iterative development that led us to the workflow which we see in here. Okay, but that is not all. As I mentioned before, we wanted our outputs to be responsible AI compliant, right? Hence, we bookend our workflows at the start and on the input side and the output side with responsible AI filters, okay? And the way we built the responsible AI filters was, it was essentially a set of different systems that came together in order to verify that the input and the output were actually safe to use. And it's important that, by the way, this is a super high-level representative flow, where how it actually works. And we use AWS managed services like Bedrock guardrails. By the way, all the things that I'm mentioning right now to you, like Bedrock, recognition, comprehend, the Lambda functions and everything like that, it's available. We use the same thing that everyone else has on AWS. Okay, so the Amazon Bedrock guardrails, they actually help us detect sensitive content like PII data. PII stands for personally identifiable information. We can define denied topics. Let's say someone is discussing about stuff that we want to not return outputs for, so we can define them. Then we also use, these also work as sort of input and output filters for our foundational models that are there. Secondly, we use Amazon recognition. It is to detect inappropriate images and videos through categorizing the assets against the, did I lose my? Against the categories of images that we do not allow. Amazon recognition also helps us to detect like celebrities, text on images, and on videos. Then Amazon Comprehend detects PII-sensitive information. Last but not the least, we have our custom rules-based filters, which we use when we need to have much more fine-grained controls as guardrails. Okay. Now, going back, this constitutes the entire image generation inference flow. We built this purpose-built solution, and again, I want to repeat, this was a purpose-built solution for text to image back in 2023. Okay. But like with every purpose-built solution, we could only scale it so much. And it can only be used in so many use cases. It did a great job of helping us deliver the image generator experience in 2023, which was announced, like there's global PR around it. But then in 2024, we needed to scale it to support the hyperscale of Amazon. Now, so what we decided to do was we had to scale out our offering, and for that we wanted to do bulk generation of these images. Now to do bulk offline generation, guess what we had to do? Do you think we had to rebuild the whole system? Yes, no? It's kind of a leading question. Do you think we had to rebuild the whole system? How many of you think that we had to rebuild the whole system? Raise your hands. Okay. How many of you think that we could just reuse the same system? Okay. All right, cool. So for the folks who did not raise your hands, I guess you think both of those things happened? All right, no, that's not what we did. So we actually used what we call as the AWS multi-account strategy that is there, where it helps you isolate online versus offline flows. But you can deploy the exact same thing. And the reason why we wanted to isolate the online versus offline workloads, and online is when an advertiser, a human, is actually using the system, versus offline, we classify that as like a batch process or something like that that we can run on the back end. Bulk generation was an offline process. And we wanted to make sure that the offline process does not impact the online user. Because imagine, right, like I start a backend job, then there's an advertiser who's trying to do something, and suddenly, like, you know, it's getting throttled, right? Their requests are getting throttled. That's not a good experience. So stuff like this actually helps us have independent scaling controls. And the independent scaling controls allow us to say, hey, now we are going to run a big batch, so scale it out horizontally. And once we are done, we can pull it back down. Whereas the online workload remains constant, it remains untouched. So the exact same software, just as a multi-account strategy. Lastly, what we call as a CDK, or the Cloud Development Kit, it provides these reproducible environments. Okay. In summary, now you might think that Amazon is this huge company with limitless resources. Okay, but that's not how we operate. Like I've been at Amazon since 2022. That's really not how we operate. Like it's our startup culture that enables us to have these ambitious goals. And also we have this 2 pizza team structure, which requires us to be scrappy. It requires us to work like a startup. So we started out small, but with big goals, and with iterative prototyping, we blazed our path forward. Our centerpiece of the entire inference workflow was essentially SageMaker platform. We directly deployed SageMaker, our workflows and our models onto SageMaker endpoints, and we knew that we would want to scale to other offerings, but we were just obsessed about delivering that one functionality. Okay, and then lastly, our prototypes actually showed that the composite models yielded improved results over a single model. And hence, we decided that we had to daisy chain them so that we could produce really great outputs. Now, just looking at examples, right? This is where we were in Q1 of 2023, okay? So in Q1 of 2023, if I gave a prompt saying a close-up shot of a worn-out baseball in dirt, it actually it produces something, kind of a ball. It's like spherical. There's a little bit of dirt. The ball is. It's kind of underwhelming. Do we all agree? Yes. Yeah. But then, currently, with our new models, the same, like with the new models, but similar workflows, this is what the output is. And so this has just been over like the last couple of years. There's another example where the prompt was like this: 3 oranges on the railing with the sun setting in the background. You can see the oranges are on the railings, but they're like kind of flying, right? This doesn't look like true, right? So, I mean, there is the sun somewhere, I would say, and there are 3 oranges, there is a railing. But then, currently, this is what it produces, where the oranges are actually nicely placed on the railings. It is understanding that. You can see that, like, hue of the sun, of the setting sun, right? So it starts to look much more realistic, okay? And that just shows that, like, things are evolving. But then this was just image generation. You put in the text, you get the output of an image. And we were like, but can we do more, right? Is there something like that we are missing? So then we started with the product detail page, and we created stunning imagery, which can be used in ads, right? But then we also started to add like subtle motion. So can you see the flame in the background, like flickering of the candle, right? So that's the thing. Or stuff like this, where we could have a pan of this, the lavender fields, right? So we wanted to see how far we can push the boundaries of our tech and of science, and our science. What else could we do? Now, not just the sort of the panning of the camera angle, like, having that flickering flame, etc., etc. We wanted to see how far we can go with just, like, these different subtle changes. So what it does is it takes in your AI-generated images. We launched something called as Live Image. It takes in your AI-generated images, and with just a click of a button, it will start to apply fluid camera movements. So let it be like, your, like a steaming cup of coffee that you have, and then it's on a nice picnic setting where you can see the steam is rising, or it can be a bouquet of flowers which is gently swaying in the wind, or it can be the night sky just moving, right? And all this was possible with like a click of a button and using generative AI. Okay, we call this Live Image. Are you all interested in knowing the tech design for that? Yes? Okay. Really? Or you all want to break for lunch? All right, we've got 15 minutes. So let's look at it real quick. So this was our image generator, right? Right? Now what we did for Live Image is we just took that same architecture and we added a couple of more steps. Okay? And we added a depth-aware video frame generation, and we added an image-to-video model, so to say. Okay? So we generate the images. Sorry. So we generate the images. Yeah, we generate the images, then add depth to them, and then convert them to videos. Now, if you recollect, we built a purpose-built solution for image generation, correct? Now we wanted to scale it. We wanted to improve it. So, like new use cases like these, we just needed to handle them. So we started out here. This is your image generation inference that we have already seen. Then we needed to also give stuff like image editing, right? Because then the advertiser started to say, hey, I just don't like these two things. Can I go edit them? Can I resize them, right? So we wanted to enhance the images and give advertisers the ability to actually edit. So what we did was we provided them the solution where by typing what they want to do, like they can start editing images. What we do is, based on their inputs, we actually enhance them because sometimes, like we are not expecting everyone to be a prompt engineer, right? We want to help them. So they can just have natural language prompts, which we take, we infer them, and then we enhance them. And then this is what enables the editing model to output, like based on the advertiser intent. Now, as we see, these all workflows, like we just saw 3 workflows, by the way, they're all same, but yes, but they're slightly different, correct? Right? So we needed to invent new solutions on behalf of our customers. And for that, we needed to prototype, build, understand, and iterate rapidly. Okay? That was the most important thing. Like, and another thing was, prototyping was not, just prototyping wasn't enough. It wasn't, we didn't want it to be in like, hey, works in my local situation, right? We actually wanted to ship them to production so that people, advertisers could use it, okay? So we just needed to rethink about our processes to take things to production. So let's actually look at how the entire process to go to prod was. The biggest bottleneck that we found was we had scientists work on prototypes. Then there would be a back and forth between the scientists and the engineers to say, hey, this is what the workflow looks like. Can you take it to prod? And then using those notebooks from provided by the scientists, the engineers would write code, and then there would be a constant back and forth between them. Then the engineers would stitch these models the way the scientists expected them. Then the scientists would be like, no, this is wrong. The engineers would be like, hey, this API and these interfaces are not compatible with each other. What's going on? And then it would be like, a long process. Does this sound kind of familiar? Like working with, okay, cool. So what we did was we needed to completely rethink in which we were going to work, okay? And for that, what we decided to do that, the engineers would actually work on what we call as a model registry, and then the model, so this is the whole back and forth where the engineers would convert the models provided by the scientists, and then they would deploy, and so on and so forth, right? So we decided to simplify the process altogether. What we did was, we thought if we could streamline the process in such a way that scientists would keep on writing the code as if it was like science models in a very declarative fashion. I'm going to zoom into each of these blocks, so just give me a second. And then the engineers were actually writing the code to interpret what the scientists had written. Okay, so what we did was, and we actually worked with the scientists to understand what was their most favorite or most the programming language that they were comfortable with. The scientists equivocally said that they wanted to use Python. So we actually built an intuitive Python-based environment where we encapsulate all the workflows, that are there. And they are essentially written in such a way that the Python-based environment is very declarative, okay? So all they had to do is they had to say workflow, they had to say the task, and then they could just write it in a declarative way, all right? They did not have to manage how things, what the API is going to be, what the interface is going to be, so on and so forth, right? And then we took that and we actually gave it to the engineers, where what the engineers did was they wrote the code which would interpret that declarative workflow, and then it would convert it to a workflow graph, and using that workflow graph, we would actually deploy them to the necessary AWS resource. Okay, this allowed the scientists to focus on building workflows as completely separate tasks, and engineers to actually focus on innovating the actual engineering problem so that the scientists could be independent, okay? Now, using that, what ended up happening, as I mentioned before, is this Lambda orchestrator interprets the workflow from the SDK that the scientists have written, the declarative workflow, and then converts it into this workflow graph. And then the same workflow graph that is there for individual tasks and steps get deployed on the necessary AWS resource, right? So let's actually look at the declarative workflow. It's as simple as this, where we introduced annotations like at workflow, and this is the live image workflow which exists right now. And using these annotations, this would be the start and the end. And now let's start filling in the blanks. We needed the product info, which we got. That's it. Check, right? Then we needed to process the input image that was there. Another task, done. Then we needed to generate the live image. Another task, done. And you can see like it's much more functional style programming. And then enhance if it was needed and return the live image, right? Now similarly, a declarative task that is there, this is a task to generate the live images. It's quite straightforward. It takes in the inputs, some parameters, and a predefined model. It invokes on that model. Now remember, I'm saying it invokes on that model, okay? Now that's the beauty of the declarative style, okay? We don't specify how to invoke the model, whether it's going to run on a Lambda, whether it's going to run on SageMaker, like what should be the memory, what should be the instance, which environment, blah, 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 right? All that is hidden. Like all that setup is completely hidden. It's all that data is carried on the model itself. My philosophy is like the system should just know. Like we shouldn't have to keep a track on like what is happening over here, right? And then on the invocation side, you have to do certain like again you can see that that's the class SageMaker model, okay? Where we know that the model runs on SageMaker, and you have to do some initial setup, which is like one time like which environment it's going to run on, so on and so forth, all right? And then the runtime specifics like region, environment, etc. are auto-initialized. It's super easy, it's efficient, and it's effective. Now, looking at the actual invocation, this is just a straightforward delegation, right? It just says invoke real-time. I'm not showing the async execution, but you can imagine it's similar to the real-time flow with just some checks like whether something is complete and so on and so forth. Now, distilling down to how the invocation exactly happens is we use something called as POTO3, which is like a runtime client that AWS gives. And then using that, we just make the call to that necessary endpoint. That's it. Everything is just encapsulated, and things just fit well together, and it just works. Isn't it amazing? Like you don't have to do the same thing over and over again. Like the scientists can actually write their workflows and then just deploy them. This makes the engineer inside me extremely happy. I like the beauty of the system, you know. This is an example of the runtime client that I was talking about, right? Now using this, we were actually able to scale out our functionalities, like image generation, editing, live image generation, image product resizing, styling, themes. But then we were like, how much farther could we go? Can we do more? Can we? So we actually launched something called as a video generator last year, where similar to the image generator, by just pressing one button, the advertisers can actually create a video from their product itself. So similar to this, like they select the product, they say they want to AI generate a video, we give them 4 options, and they can select one, they can add it to the campaign. Boom, done, right? Let's look at, like in the interest of time, let's look at the actual architecture for video. I've got 5 minutes, so I'm going to go walk through this real quick. So this was the live image generator architecture. What we did was we needed to add a few more workflows to actually generate a video, Okay, and as you can see, these are just like building blocks that just go on adding. Okay, so one is a text-to-image video model that just produces a video based on the text that is provided. The other ones are like which you have already seen for the live image that is there. Now, the interesting thing is, we also wanted to add headlines to our videos because our videos require headlines to grab the attention, right? So actually zooming out, this is the whole architecture that exists, okay? Now, because we invested in actually changing the way we built the image generator model, because remember, the image generator workflow inference setup was a purpose-built solution. When we started doing live image, we added a few steps. And then we realized, hey, we just can't scale it anymore, right? So we actually invested. We went back and we simplified the process. And using that, we were actually able to create this entire workflow process, right? And you might think, hey, but which is this text-to-video model? We use what we call as an Amazon Nova Reel. It's available for everybody. It is a generative AI video creation model, which does text-to-video for 6-second clips. And lastly, in the last 3 minutes, I do want to share like an example of a whimsical world of pasta that we actually generated. And this is generated using the AI model, where you've got like meatballs, you've got some yeah. Right? I mean, I was kind of amazed when it actually came out that like, hey, it's a magical world of pasta, right? And remember this is just what, in the last couple of years. It's only going to get better, okay? It's only going to get better. And now with that, I just want to end the talk with some of the key takeaways that were there. So first of all, and again, these takeaways are irrespective of whether you're using a generative AI system. I wanted to keep it much more abstract, but I showed you the power of like these principles so that you can use it for your day jobs as well. So first one is you should separate the online versus the offline workflows or your calls so that you get the independent scaling controls. The second one is the SDK working model that I discussed, where the very first step is you have to understand what the process is. You want to identify what exactly happened, and then, what exactly is happening, what are the shortcomings are, and then you want to decouple as much as possible, okay? And using that decoupling is going to help you accelerate. Lambdas are fast to prototype, test, and iterate. We actually use lambdas to, in an async fashion, to avoid idle time and optimize resource utilization. We use AWS Fargate for long-running processes. The video generator that we saw, that actually runs on AWS Fargate because it requires much larger memory as well as it's a long-running process. Lastly, this is something that I want to leave you all with. Infrastructure changes are going to be necessary. It's just how it is, right? Like how many times we have had to upgrade our version of Java or change a machine, right? That's the thing. But it's our responsibility as software developers to ensure that they're transparent to your stakeholders. It should just work, okay? With that, thanks a lot, everyone. I hope you enjoyed my talk, and I'll see you around. Thank you. That's my LinkedIn. Feel free to connect. Make sure you give me feedback, and if you liked it, please give me praise. I wouldn't mind that. If you didn't enjoy it, also give me constructive criticism so that I can improve the talk. All right. Thank you.